We've been talking a lot about Atlassian Connect today and yesterday, and one of the things that makes me really most excited about Atlassian Connect is that it enables people who want to build add-ons for JIRA and Confluence to use a ton of exciting new modern web technologies. And one of those technologies that is particularly cool is Firebase, which is basically a whole new way of thinking about like how a database should work in a web application. And so to tell you about Firebase and why it's really cool and why it can work great with Connect, we have Osama Alami, who's the VP of Developer Happiness at Firebase. And he's going to share what Firebase is, how you can put it to work, and then do a demo of using it with Atlassian Connect. So Osama Alami.
Thank you. Hi, everybody. Welcome to Building Real-Time Add-ons with Firebase and Atlassian Connect. Thanks for the introduction. My name, again, is Osama Alami. I have the typically whimsical startup title of VP of Developer Happiness, which means I run developer relations, support, marketing, and a couple other developer-facing teams at Firebase. So today, I want to walk through a couple of things. The first thing is to introduce you to Firebase if you haven't used it or don't know what it is. I'm going to talk about building an add-on, but building an add-on without worrying about spinning up a server. We're going to do a sample app, two sample apps, actually. The bigger one is going to be a collaborative planning poker app with JIRA integration using Atlassian Connect. And then I'm going to talk briefly about how to secure a cloud database like Firebase and talk about deploying your app when you don't have a server. And then we'll give you some resources that you can use to get started. So how many of you have actually heard of Firebase? It's pretty good. It's about half of the audience. Well, for those of you that don't know, Firebase is a platform for building applications without a backend. You can focus on solving the problem that you want to solve all with front-end code. And Firebase will take care of your backend and scaling up as you get more users. And we do this all in what we call real time. So our clients, when you use one of our SDKs, it provides data to you as it changes in the cloud database. So the core part of this platform is our real-time database. It lets you as a developer using front-end code sync and store data across clients to a cloud database. On top of that, we have security and authentication methods that let you easily authenticate users. And since obviously this is a cloud database, to define methods to secure your data, either based on users or based on that data structure. And then in May, we launched a hosting product, which we call production-grade hosting. I'll talk about that in a bit. So the cloud database itself, the real-time database, is a NoSQL database in the cloud. You store JSON objects and retrieve JSON objects. Each piece of data has its own unique URL. I'll show you that when we go through some samples. And then when you use our Firebase SDK, your client, your front-end application gets notified when data changes at a node that it's interested in knowing about. And then beyond that, we also have a RESTful web API where you can use to access the database in a traditional RESTful fashion. So since we're building an add-on for Atlassian Connect, we're going to do it in JavaScript and HTML. Most of the samples here are going to be JavaScript. And I want to briefly show you what it takes to get started with the Firebase. The first thing we want to do is create a reference to our data. So the first line up there is just creating a new Firebase reference. And our data happens to be at atlassian14.firebase.io.com. And then I want to store a piece of data to that Firebase. On the reference that I've created, I just call set. I'm passing in a string in this instance, but I can pass in an arbitrary JSON object or a number or a list. And then to read data from Firebase, we actually attach a callback that gets notified whenever this data changes. So there's no need to re-request data or do any sort of polling on your end. This callback will automatically get triggered whenever data changes in your Firebase. In this case, you see ref.on. I want to get notified whenever the value of that node changes or any of its child nodes change. And then I just get the data by calling snapshot.val And in this case, I'm just logging into the console. So I talked about JavaScript. We have a JavaScript SDK. But if you are building a mobile app, we do have a native Android and iOS SDK. And in fact, if you are building something on the web and you have your favorite framework, be it Angular, Ember, Backbone, or React, we have bindings that let you use Firebase in a very native-feeling way for those frameworks. And while most of our developers use Firebase as the entire backend for their application, there are certainly use cases where you may want to access Firebase from a server. Say you want to connect to some other service or want to do some data analysis on your own servers. And in that case, we provide a Java SDK and a Node.js SDK that you can run on your server. And of course, with any language, you can access our REST API. And so security and authentication, we're running a cloud database. How do I secure my data when any front end can connect to it? We have an expression-based rules language that you define in a file that then is enforced by Firebase every time data is read, written to your database. In addition to access control, we also do things like validation, like is this data long enough or short enough, or does it look like an email, or does it match some other piece of data in my database? On top of this, since we're a platform that lets you build applications without a backend, a lot of people want to do sort of social login integration with Facebook, Twitter, Google, or others. You'd have to originally set up a server and do this whole OAuth dance. We take care of all that for you. So with one line of code, you can literally integrate Google Authentication and use that identity to enforce security rules. And then if you have your own custom authentication method, your own database of users, you can certainly authenticate that way and provide that information to Firebase so that it enforces your user-based security rules. And then hosting, I call this production-grade hosting. And the reason we call it that is we really think it ticks all the check marks of what a static hosting product should be. It's very, very easy to use. It is globally backed by a CDN. All your content is automatically distributed across a global CDN. Everything is served over SSL, HPS, so everything is secure. And then we have the tooling around this that makes it very easy to do one-command deploys and one-click rollbacks. Excuse me. So I don't want to go too far into a presentation without giving you a demo. What I have here is a JavaScript and HTML application. It's kind of a trivial drawing app. And I have it in 2 iframes in my presentation here. And as I move my cursor here, you can see it actually updates on the other screen. As I move my cursor here, it updates on the other screen. To show you what this data actually looks like, I'm going to open up what we call the Firebase dashboard. This gives you web access to your data and a data representation and lets you set all sorts of options. I should turn this off. OK. So you can see our data is structured in this tree. Let's see if I can make that bigger. And I have some cursor points. Since it's not very interesting when I have to switch tabs, I'm just going to move that over there and move this over here. And you can see as I move, let's try this again. And I lost network.
First live demo I've seen.
All right, we'll rely on the Wi-Fi. OK. Might be a little slow. Pay no attention to the okay. seems promising. OK. Are we gonna? There we go. Yay. So as I move data here, you can see it changing in my Firebase. As I move data here, you can see it changing in my Firebase. This is going out to the cloud, getting saved in Firebase, getting synced across all interested clients, and getting pushed down, and my cursor is getting updated. So this happens all very, very quickly, assuming I don't turn off the internet. And you can see I can start drawing things. It's just kind of a trivial drawing app. So that's a quick example of Firebase on its own. More about the company Firebase. We have over 95,000 registered developers. We were founded in 2011 in San Francisco. We're still in San Francisco. We launched our RealTime Database in 2012. We have lots of customers, big and small, that use us for a variety of reasons. Lots of people use us as the entire backend for their application, but a lot of developers also use us to power like real-time features in their applications. Other developers use us as sort of a transport layer between their various clients. So our customers include folks like Citrix, Atlassian, CBS, Twitch, Warby Parker, Instacart, Yahoo. Across all our sites, we have, on average, over 1 million concurrent users. That's users using Firebase sites at the same instant. And then we do billions of operations per week. So that's Firebase. Moving into building serverless add-ons. How many of you have actually built an add-on using Atlassian Connect? Cool. That's like about 20% of you. So I'll cover a little bit about doing that. And then we're going to build a serverless add-on using Firebase. So the way that you build a serverless add-on is using the Atlassian Connect JavaScript API. Your application will live in an iframe in either JIRA or Confluence. And your application will load the Atlassian Connect library directly from your instance, so directly from your instance of JIRA. And what this does is, even though your application is hosted on one domain and JIRA is running on a different domain, it creates a cross-domain messaging bridge and allows your application, your JavaScript, to access JIRA or Confluence and load data from there and set data. It also provides this AP class that lets you do just that, interact with JIRA. So what this looks like is I load a script tag with my on-demand host name and a context. Context is either JIRA or Confluence. And then this Atlassian-connect/all.js lets me load this JavaScript library into my JavaScript app. And then an example call, if I want to get user information, there's a getUser method that takes a callback. So now that we know the very basics of building a JavaScript Connect application, let's integrate that trivial drawing app into JIRA and see what it takes to do that. We'll see if we can do it in actually less than 5 minutes. So this is what, there are going to be two main components. There's going to be the configuration file, which is this Atlassian-connect.json file that defines what our application is and where it lives in JIRA. So the first couple lines here just define what the application is, give it a description, a base URL. I've actually already uploaded this Whiteboard app to this Firebase hosting URL. I'll talk about a little bit about that later. An authentication type. This might be a little confusing. Authentication is type none. That doesn't mean that our app isn't authenticated. Our app is actually running inside of JIRA, so it already has that user information. It's already authenticated. What this means is that you don't need to do anything else. You don't need to go through the OAuth flow or pass it a JSON web token. We don't need to do additional authentication. I'm only going to read data. What I want to do with this Whiteboard app is actually just show the username of the user when they move their cursor. That's the only thing I want to do. And then modules defines where it lives in JIRA. In this case, it's a general page. I want it along the top navigation bar. And I want it to load this whiteboard.html when I click on it relative to this base URL. The other component is our HTML and JavaScript. This is very, very simple. I load the Firebase client library from our CDN, and then I'm running a local instance of JIRA here, a development box. And so I'm loading it from that instance, localhost, Atlassian Connect, all.js. And then all I really need to do, I want to get that user information, so I call ap.getUser, pass it a callback, and that returns. I get that user object, and I use that user's full name to assign them that when they move their cursor. And then I call a setup function. I'm not going to go through the Whiteboard app itself, but it is open source, and you can take a look at it. So we'll do a quick demo. Switch over here. I've already installed this. You can see along the top where I defined I wanted Whiteboard. Whiteboard is right there. I'll make this bigger. And there we are. We load the previous data. I can maybe change the color, draw. This is how happy I am my internet's working. Yeah. So that's very simple, and you can actually see that I'm logged in as admin. When I move my cursor, it actually says admin. Very simple application. But in a trivial amount of code, we've added a Atlassian Connect application, built an add-on. It's actually kind of useful. You can do collaborative whiteboarding and know who your users are. For a less trivial application, since most of the add-ons you want to build, you want to access that data that's in JIRA or Confluence, right? You want to access issues, you want to manipulate issues, you want to save those issues back. How do you do that? Well, if you've used the JIRA REST API, you already know how to do this. Basically, through that, again, AP class that you're given when you load that Atlassian Connect JavaScript library, you can call ap.require, say you want to do a request. It provides a request function. You call that, passing in some parameters. In this case, I'm doing a GET request to the dashboard to get all dashboard information. And then you just give it a success callback and an error callback. And that's really all you need to do to retrieve data. So now we know how to manipulate data, and I want to build a more concrete example. And what I'm going to do is build a collaborative planning poker application with JIRA integration. So for those of you that don't know what planning poker is, it's a consensus-based technique for estimating the effort or the size of projects. And basically, players of this game get a set of cards, the values of which represent how much effort they think a project is going to take. And they get together as a group, play the cards face down. Then once everybody's played their cards, it flips over. There's some group discussion. You assign a value based on that. And what this does is it sort of eliminates an anchoring effect. If somebody early on when planning thinks that a project is actually a trivial effort, but somebody else may not want to speak up because they think it's actually a very large effort, what happens is that as humans, we tend to be anchored by that initial vocal person. So it's an attempt to eliminate that and get like a more consensus-based effort for estimating projects. So fortunately, somebody has already built a collaborative planning poker application on Firebase. This was built by the folks at WiseHive. So I don't need to build that. I'll give you a quick demo of what that looks like. This is also all built on Firebase, all front-end code. Excuse me. So I'm going to create a new game, say a test game. I'm going to input some stories. These are the things that we're going to vote on. Give. Need a cool logo. OK. So I've created this. Since this is a collaborative thing, I'm going to do my trick here and do 2 windows. Let's call this person Fred. So now I'm in there and Fred's in there. I click a presentation, or sorry, I click a story. Fred gives an estimate that's played face down. I give an estimate. This automatically sort of takes the average of the 2. I can adjust as needed, except the round, and it sets that value, 25. So this, again, was all written in front-end code, written with Firebase. Since we are essentially pulling in these issues by writing them down, and then once we have the values, we'd have to take them and put them into whatever system we're using to track them. It'd be really nice, since we have JIRA, if we can just pull these issues in automatically, and the values are automatically saved back out. So that's what we're going to build as an add-on. So our add-on's going to populate planning poker with JIRA issues. We're going to pull that estimate back into JIRA. We're going to do it all without a server. We're going to do it all in real time. I'm actually first going to give you a demo of this working. Note that everything that's running here is all JavaScript and HTML. In this instance, it's hosted locally. I just have a local web server serving up static files. The first thing I want to do is install this add-on. If you haven't installed an add-on while you're actually developing it, it's just simply going to this admin, add-ons, manage add-on screen, and then specifying the actual JSON file. So this is localhost 8000 where I'm running my server, and then the Atlassian connect.json file. So that was installed. I'm going to go to my one project. I set up JIRA with a bunch of random data using a data generator. So I have lots of issues. And while we could have just integrated that planning poker application directly into JIRA, for the simplicity of this demo and showing you how it works, I actually have like this little go-between page that lets a user who comes to here select which issues they want to push into planning poker and select which game they want to push it into. So I use the Atlassian Connect JavaScript API to make this search request to get issues. That's better. And then you see I already have this test game here. This is the one I created earlier. Let's create a new game. Let's call this integrated game. I don't need to input stories because, again, we're going to populate that from JIRA. Create the game. Switch back here. You can see this popped up automatically. It's because I'm using Firebase here. Everything happens in real time. I don't need to refresh or make another request. So what I want to do is I want to send all these issues to that game. I'll do my little trick here. I'll show you when I click send, they automatically pop up. Because again, everything is built with this Firebase model of real-time data. As data changes, your changes are reflected in your page. So let's, again, maybe play poker with 2 people. Maybe we'll run through 3 issues or so. I pick a story. Fred votes, I vote. I'm just going to accept the difference. Do this 2 more times. All right, close that out. If we go back here, we can see the data has already been populated back in. Again, everything's real time, so as this data changes, I'm populating it. And in fact, as this data changes, I am also setting a custom field in JIRA with this data. So I don't need to do any additional tasks. All this data is automatically saved. It's updated automatically. You can see I have this little poker score custom field, and that's the value that we had. OK. So how did we build this? Again, 2 parts. There's the Atlassian Connect JSON file. We talked about this already. I'm just adding an additional write scope because I'm actually setting issues as well. I want it to live in JIRA project tab panels. Here, the URL is just index.html relative to my local host. And I want JIRA to pass in the project ID so I can populate that JQL string with the project ID. And then I wanted to say play fire poker. Weight is just weight you can assign to the link to determine where it shows up on that tab page. The bulk of it is obviously in JavaScript. It's a little bit more complicated than the last one, but it's pretty simple. The first thing I want to do is create a reference to my Firebase. I've created this new Firebase at-poker, and I'm dealing with everything under this games node. And then these are some things I'm just saving for later. I use some jQuery, ugly jQuery, to wire up the buttons. And then the first thing I want to do that's interesting is populate the game list. Remember this updated in real time. So on my games reference, remember this URL up here, I want to know whenever a new child is added at that node. You'll notice last time we used value. Value is anytime anything changes at that node. This specifically will only tell me when a child is added to that node, which is exactly what I want to know. And when a child is added, I'm just getting the value of that child as the game ID. I'm getting the key to that node. And then I'm just appending it to a div, which is how that shows up in real time. The second thing I did was I searched JIRA for issues. This is, again, just a GET request. We already saw this in the Whiteboard app. I call the REST API with the search endpoint, pass in the JQL. What I'm doing right here is my data is formatted in the Planning Poker app in a specific way, so I'm just building that out and throwing it into an array. I haven't pushed it to Firebase yet. When the user says send to Firebase or send to Fire Poker, I'm going to do the work here. The first thing you can largely ignore, I'm just, in case a user has done multiple games, I'm clearing out the old query because I don't care about updates to that anymore. I'm getting the current game just from that text box, and then I'm creating a new reference specifically to the stories in that game. So if we look at this, we're calling ref.child of the current game. Again, ref is this. .child current game is this, where game ID is some arbitrary ID. And then I'm interested in the stories, which is stored under a stories node over here. And then I set the issues. So this is just the array that I populated earlier. And if we go into Forge or our Firebase dashboard, you can see this data is all populated in here. And then the last thing I want to do is I want to update the data as it changes. As we have values, I want those values to get populated both in my HTML page as well as in JIRA. So whenever the status, so I attach on that stories ref a new callback. I want to know whenever a child is changed. So we've seen value, we've seen child added. Now this child has changed. As you might guess, there's also child deleted or child moved. But anytime a child is changed and the status of that story is now closed, as in the vote has been accepted, what I want to do is, A, just using some jQuery, update that HTML page. And then this is the first example of making a put request, a request that changes data. It's very similar to the GET request. The only differences are that I specify a type of put. I'm obviously calling the REST API at a different endpoint and passing in the issue ID, which is stored in story.notes. And then I specify a content type because I'm setting the data using JSON. And then I specify the fields. In this case, this is my custom field, poker score, pass in the points. And then again, I'm just logging the stuff to the console when it's done. So that's it. That's all it took to integrate these two applications, to integrate JIRA with data into this collaborative planning poker app that I found on GitHub and forked, and get that data back into JIRA. It was something less than 100 lines of code. The next thing I'm going to talk about briefly is security and authentication, authorization rather. Again, what I've shown you so far, I just created a Firebase with default security rules, which means anybody can read and write to it. In production, you'd probably want to specify some security rules. The security rules are specified in this JavaScript syntax, It controls read and write access to your data, as well as controls how data is validated. And then if you use something like Firebase Simple Login, which is that one-line authentication with like Google or GitHub or Twitter or Facebook, you also get this auth variable in your security rules that you can use to validate a user. If you don't want to use any of those authentication methods, we also have custom authentication that lets you specify an arbitrary data like a username or like is admin true that then is encoded using a secure key and sent to Firebase that lets you send arbitrary data to determine how your security rules are enforced. Authenticating users briefly just looks like this. I use a new Firebase Simple Login. I pass in the reference to my Firebase and a callback. This callback basically has 3 states, an error code while attempting login, like a wrong password or not authorized. Otherwise, if I have a user object, then the user's been authenticated. Otherwise, the user's log out. And then here's my one line of code. You can imagine hooking this up to something like a sign-in with Google. I call authclient.login Google, and that kicks off the OAuth flow. There are a couple other steps, admittedly. If I go to Simple Login here in my Firebase dashboard, you can see I just need to specify a Google client ID and client secret. And then I'm done. I don't need to worry about the headache of OAuth there. And then once I've authenticated a user, I have to write some security rules to determine what to do with this authenticated user. In this case, this is just an example. Security rules reflect the structure of your data. So here I have, let's say, a users node and then a user ID. This is a variable. What I want to have happen is whenever a user writes to a node that is their ID, I want to make sure that they are the only person that they can write to that node. And so I specify a .write rule that says the user ID here must match the actual user ID using this auth variable that I have. And then I write a validate rule to say if the user sets an email address. Again, this is all front-end code, right? So the front-end code is actually saving this email address. I want to make sure that the email address is actually the user's email address, because I actually have access to it through auth.email. So I won't go into detail on how to secure our actual add-on that we built. There's plenty of documentation on our site, or I'm happy to talk about that. It would take a couple extra steps. I don't really have time in this presentation. But I will talk about deploying our application. So we've built an add-on using just front-end code, HTML, JavaScript. We still need a place to host it. You don't have to use Firebase hosting to use Firebase. And in fact, you don't have to use the Firebase RealTime Database to use Firebase hosting. But it is a very easy way for you to build an application, launch quickly with one solution, the RealTime Database, and a hosting service. So what it takes to launch or deploy an application to Firebase hosting is simply install the Firebase command line tools using npm, which is the node package manager. Run Firebase init in the directory you want to deploy, and then run Firebase deploy, and that deploys it out to our origin server, and then invalidates the cache at the CDN. So all that data is now up to date and served globally. I'll show you very briefly doing that to our Whiteboard application. I like to risk everything with live demos. So what I have here is just my Whiteboard application. I've already run Firebase init. What Firebase init does is it generates that Firebase.json file. All that is the configuration file. I'm pushing it out to at-poker. The public directory is here, and then I can ignore things or set up redirects or whatever you would expect with a hosting product. So now that I've already set that up, I just run Firebase, Firebase deploy. Everything runs super fast. And you can see it is now live at atpoker.firebaseapp.com. So it actually uses with JIRA. I would just change that Atlassian-connect.json file to refer to this URL and go through the install flow. So our app is now deployed at this firebase.app.com subdomain. You can actually use a custom domain with Firebase hosting. It gets you the same exact benefits of being served over SSL and served over a global CDN. And in fact, we do the extra step of taking care of acquiring that SSL cert and installing it, so you don't have to go through any of the pain there. This comes included with all of our paid plans, free custom domain hosting. And that's it. I'm going to point to a couple resources and then open up for questions. If you are now convinced and you want to try Firebase, we have a very quick 5-minute tutorial at firebase.com/tutorial. Our docs and the Atlassian Connect docs that I used to build this sample are all there. The actual samples themselves are hosted on GitHub under my repo /Atlassian14. And this presentation itself is also hosted on Firebase hosting. You can access it there right now.
Give it up for Osama. All right, there were a couple questions that came in over on Confluence Questions, and feel free to vote some more up or add some more, and we'll get them on here. So first question, does Firebase require WebSockets?
That is a great question and a good guess. Firebase does do its real-time connection over WebSockets. However, our clients are smart enough, and WebSockets implementation vary across browsers and different platforms, that where a WebSocket is not able to be established either due to like some firewall rules or because the browser doesn't support it, we fall back to long polling, which again acts as a real-time because the connection stays open until data changes and then that data is sent back. This is all transparent to you as a developer, so you get that real-time functionality regardless of whether we're able to use WebSockets or not.
So how many hits does a typical custom field generate when viewing an issue? Something you know?
I don't know what this question means.
So are there any JIRA experts in the room that might want to jump in on this one?
I asked the question.
Yeah.
I can take one I'm asking for. So if we have a custom field that we're looking at taking into a non-connect plugin, and we're just wondering how to guess what the usage will be. You know, if a single customer installs a plugin, how do we guesstimate how many hits it's going to create in Firebase when they use one person views one issue?
So how many hits?
I mean, it would probably depend on the number of people, or how many, the size of the project, the size of the instance, how many. I mean, it's one hit per page view, right, or per page load, right?
When the issue's re-indexed, right, the Atlassian indexer will run across your issue like 20 times. It's okay.
Sorry, I'm not necessarily a JIRA expert.
And I have an add-on that doesn't require a backend, but I like Firebase. Can I use it anyway?
Yes.
I think that's a trick question.
You can certainly use Firebase hosting. If it doesn't require a backend at all, you're not persisting data anywhere, then Firebase hosting is still a great solution for you to to host that add-on itself. And then, if you do want to add some collaborative features, it makes it very easy to do that as well.